Hello future engineers, and welcome to a quick video tutorial on the rotational motion constraint inside of Inventor. So what our goal is for today is to make it so that when I turn one of these gears, the other gear turns as well. So what I have right now, I have two gears that are constrained to my back plate over here. How I have them constrained, there is a mate constraint that keeps them connected to that back plate. And then I also threw in these little pegs that I designed so that there is an axle right here, or an axis, and a complementary axis over here so that it rotates around those axes. You can see that I have my pink placeholders that fit right there. So the center axis of this one is mated to the center axis of the gear. Cool. So that allows them to rotate freely and stay in position. It's really important that before we get started that our teeth are in mesh. What I mean by that is that the teeth line up so that they can easily push each other and that they are not actually interfering with each other. So not too close, not too far away. If you have these pegs inserted into the proper spots on a VEX board, they do all the distancing for you. And this should work with every single gear that you have available with you. You should always be able to find some kind of complementary mesh state for these. So they have the perfect distance apart from each other. And now I just want to move this so that they are in mesh. You can see that's just about good. There's a little bit of space right there, but because this is a simulation, it's hypothetical, it's okay. We're not gonna have it so where they are exactly touching. So there we go. They are now in mesh, and we are going to throw in our rotational constraint. So I go over to Constraint, and I choose my Motion tab. And then we have two different types. We have rotational and rotational translation. So we are going to choose rotation for our first one. And we want our solution to be opposite of each other, reverse, so that when this one is turning forwards or turning clockwise, this one turns counterclockwise. Remember, gears alternate every single time that you have them if they are in a row. So as this one turns clockwise, we want this one turning counterclockwise, and vice versa. So I am going to choose the faces of each of these as my selection. So you can see both of my red cursors have vanished. I have selected both this face and this face as my rotational face. And now I'm going to hit apply, and we're going to see what happens. When I rotate this, yes, it is working. They're rotating, but they're rotating at a different rate on the outside. Because they are different diameters, this one, the teeth are going to move a lot faster, the larger gear, than the smaller gear. So what we need to do is we want to, one, get this back to where they are in mesh, and then I'm going to edit that rotational constraint. And inside of this ratio, I'm going to throw in my gear ratio. So I have my number of teeth, so I've got 84 and 36, so I'm going to go 84 divided by 36, and I'll hit OK. So now, when I rotate this, they rotate at the same rate. It's perfect. Nice in-mesh teeth. Gets a little bit dizzy, disorienting when you're doing that. But there we go. That's it. Thank you for watching. If you have any questions, please reach out.